Good evening. My name is Baranganani Brandon Chilamurere. I'm here to do presentation for final portfolio. This is my PowerPoint presentation. Abstract. The energy crisis is one of the major issues in South Africa. Power utilities are struggling to collect the revenue due to electricity theft. The use of renewable energy is becoming popular as a result of the load shedding and increased tariff from Eskom. People across the country are selling counterfeit prepaid electricity voucher and bypassing electric meter. And evading payments and tampering with the energy meter and disconnecting the neutral from the return path, and these are also considered as electricity theft. The loss of revenue suffered by Eskom due to crime contributes to the needs of the national power utility to increase the tariff fee charged to paying customers. This assignment proposes a bi-directional energy meter This assignment proposes a bi-directional energy meter for a grid-tied inverter for reducing electricity bill. Bi-directional energy meter measures energy in two directions: the energy from the grid and the energy to the grid. A solar photovoltaic is the most commonly used renewable energy source. Introduction of and background of this. The South African utility are struggling to collect the revenue due to electricity theft, as I've mentioned in the beginning on the abstract. The problem statement. The cost of the electricity is high because of the crisis we have in the country. Even though this is caused by illegal action, it is still continuously a problem, especially in the areas where smart meter haven't been installed. The smart meter record the consumption of the electric energy and communicate to the supplier for billing and monitoring to prevent loss of revenue. However, the need of a bi-directional energy meter is important as a renewable energy in becoming a popular. These meters will have to assist in reducing the cost of electricity by using more of the energy self-generated and selling the remaining energy back to the grid. The problem in designing the energy meter. The problem is how to simulate to gather the correct components, how to simulate the circuit, how will the whole circuit operate, how will I implement the prototype, how to test the device, and how to read the meter. The aim and the objective of this project is to design the system that will compare the amount of the energy consumed from the different source of energy, namely solar and the Eskom power utility. The idea is to give the customer a clear picture of what he or she is consuming from both supplier, or the system will be able to predict if there is any excess in power generating from the solar, hence allowing the customer to send back that power access to Eskom grid, and the system will be controlled by microchip from Arduino This is the system that this is a transmission system that we have generated. As you can see, the PV system is solar and the solar inverter, and there is my bidirectional meter, and then there's a ESCOM site. So, which means you can see the system. If I'm supplying, I will be getting the supply from both sides, from the solar and then from ESCOM. So my energy meter will be in the middle, and there will be a load under, so it will be reading from both sides. If the ESCOM, the load shedding comes, then the solar system will take over, then the meter will still continue to read. System performance indicators. The aim of the project is this aim is still constructing that energy meter, but in our case, though, this source will be ESCOM and the solar energy, since the focus is to reduce the carbon emission, hence the choice of the solar energy. A successfully completed system must be capable of performing the following. The system will comprise of a LCD and a microcontroller that both works on a DC. The power supply must be able to convert 220 volts AC to 12 volts DC. The device must be able to carry a current of more than 100 amp for a certain period of time without generating heat. The system must be able to display in a real-time voltage generated, the energy consumed, and the amount of money that the customer is owing or is owed by the power supplier. The system must possess the safety mechanism that prevent the two sources of energy to operate safely. Under no condition the grid and the solar power will work at the same time. The connection of the system must be according to South African national standard, and all application of generating interconnection must be submitted to the electric company prior to generation connection. The generation must meet the specifications of the net energy meter rider, which specify generator capacity and the renewable energy source. The generation equipment must meet utility, product safety, and grid interconnection specification. For example, an external disconnect is required within 10 feet of meter location. An electrical inspection is required prior energizing a generation interconnection choice. Delimitation. This project is limited to design the construction by electric manage the grid. The design of other components used in this design will not be shown. This means it's also designed for residential and commercial entity exploring own power generation. Significant of studies. This project will benefit a lot of people and encourage them to self-generate power because of the advantage renewable energy sources have. Those sources are free and easily regenerated and have low maintenance costs compared to the generators. Reduce high electricity bill. Renewable energy doesn't run out like other fossil fuel. However, there are also disadvantages of renewable energy because they are weather dependent, expensive, require a lot of space, and location sensitive. Literature review. The topic explored in this project is explored by many people around the world. Below is some of the work done by other students. Example, a microcontroller based bidirectional energy metering for domestic users. It was one of them. And the abstract, it was almost the same scenario, the present energy scenario is greatly alarming. The energy consumers to conserve as a fossil fuel are going to deplete shortly. In this regard, the renewable energy system are really gaining momentum. We move to theoretical background. The voltage generated by the national grid, which is ESCOM, is normally 220 volts plus or minus the 10% tolerance. When a certain load is connected to the grid, a current will be drawn, and when the current flow in the circuit for a certain time, the energy is consumed based on those basic principles. The energy consumed by the system and can be measured in both directions. When the grid is off, the house will rely on the energy produced by the alternative source, which is solar. The energy must be calculated and displayed on the LCD. Once the power is back, the energy consumed from the grid will also be calculated. This is a circuit for induction type of energy meter. You can see our AC supply on the side and the load. It has a shunt magnet, a braking magnet, and the current coil. That's our energy meter. Methodology. Solving this problem will require a certain step that we are going to take in this section. Problem definition, do a research on the topic, and then the select a suitable solution, purchasing of the components, simulate with the appropriate software, building the prototype, and test the prototype. Compare the result with the specification. This is our design, the circuit design or system information. You can see our PVC solar panel and a voltage source DC, which is our battery. It's going to the relay board, and we have a screen LCD there, Arduino, and a current sensors. We have 2 current sensors and 1 voltage sensors, and the load, which is our load that we measure. We were using 30 watts as a load. For a bidirectional energy meter to function properly, we need at least 2 sources of energy in case we will use the solar source or national ESCOM grid. The principle is simple. When there is more than enough energy produced from the solar system, the customer will not pay the municipality any amount of the energy, the energy meter will check how much did the customer produce and fed into the tariff set by ESCOM. The relay board will ensure that the 2 sources of energy do not come into a contact at any particular time. The Arduino system will be like the brain coordinating the entire process. Since the energy is equal to the product of the current and the voltage multiplying by the time, hence there is a need of using the current and the voltage sensor in the project. The LCD will display the amount of consumed from the national grid and this national grid, which is ESCOM, and the solar source. Yes, mathematical formulas that we have used. We use the Ohm's law, and we use energy consumption, and then we use the current carrying capacity formulas. So the calculation of the components and power rating. The selection of the components. Those are type of the Arduino, and then our meters, power supply, and LCD display. Those are part of. After application of formula, the following component will be used in the accomplishment of the project. In case any of the component is missing, alternative option will be selected. A regulated power supply of 220 to 12 volts, switches, relay, energy meter, regulated power supply, and solars. So we move to the simulation using the right software. This is our simulation for voltage supply circuit. If you can see, when we go closer, you see the voltage there. There's a 12 volts of our power supply. You can see the reading, and then 5 volts there on the simulation. We move to two separate sources. This one is a SCOM circuit, and then you can see the light there is on, and the other one is solar supply circuit. Also the light is on. We move to a fabrication of a prototype. The project will be a build on the electronic boards and then tested. The picture below represents the material that will be used to complete the project. We will need an energy meter, an Arduino board. A load in our case will be a set of a light bulb. An energy meter. Once the simulation process is successful, that the construction of all components will commence. Hence, you saw the simulation part. It was corrected. The bulb was coming on. That's why we move on the a phase of building the project. This example of power supply, where you can see there's a power supply with two sensors in the Arduino board. These are current sensors. We needed 2 of them. This energy sensor for this project will be alternating current. The module is capable of measuring up to 380 volts and 10 amp RMS value. Its advantage are an isolated voltage and current sensor, which is good to prevent damage of electronic components integrated to it. This is a DC relay. As you can see the circuit. That relay, it requires 5 volts to operate and the capability to switch currents up to 5 amp. So a 5 amp fuse will have to be connected in series with the load to protect the contact of the relay against the welding and damage. So the DP-DT relay will be used as a changeover switch from the functional block diagram. As you can see, there is a LCD display. It's our screen that it shows us how much voltage is there. 220 the current. Costing of this project is this project is an ongoing project. The final price will be given on the last project. The reason being, most of the material are imported from China, and due to the to some parts are not readily available, the prices are going up. But the maximum figure that we come out with this project was 10,000 of those components in building and transportation. These are the items. Some of them like 10 amp circuit breaker, and then transformers, insulation diode, LED resistors, voltage regulators. Functionality test and discussion. Results obtained from the different runs of experiment or simulation. To evaluate the accuracy and performance of this power measuring meter, trusted measuring instrument like a multimeter, can be used to ascertain the accuracy of energy. The HLW8032 can measure RMS voltage, current, and active power, and the power factor. Those values can be recorded and compared to the value obtained from the trusted instrument. The comparison should reveal the level of accuracy, and should the reading deviate, then a calibration factor should be used to multiply the value to adjust them towards accuracy. The test was done, as you can see, voltage and currents reading on the multimeters, and the energy also. You can see the amp. You can see our LCD displaying. The compliance also. You can see the AC and DC rectifier shown. The challenge is the main highlights error occur as a result of purchasing mistake. The salesperson at the electronic retail shop mistakenly gave me 24 volts relay instead of 12 volts relay. Those relay are the one that consistently constituent the selector switch. So actually, when I say that those relay are not working correctly, because I was causing to burn most of my electronics. So instead that 12 volts, those relay are the one that I decided to select this selector switch. So to overcome this problem, I had to purchase an additional component in a form of DC to DC booster converter. Since the AC DC power adapter is 12 volts, 24 volts output from the DC to DC booster converter will act as a main source, making it possible to energize the relay coil from the 12 volt supply. Conclusion and recommendation. The source that produce DC current, like solar panel, must be coupled with inverters. Therefore, this necessitates that the inverter be synchronized with the grid frequently to avoid any phase displacement between the grid and the solar system inverter. The grid-tied inverter will be the solution to this. When coupled to bidirectional energy meter. That was my presentation. Any question? Thank you.